Welcome back to Unit Circle Day 2, Clip 2. We had talked briefly about what we were going to do to find the angle using the terminal side, and somehow we got cut off. So here we go. Let's dive into the example now. Find the angle measure of the angle with the terminal side at a given point. So we draw our picture just like we did before. I'm going to make it a little bit bigger so I can focus on something else. I've got negative 5, 3. So here's negative 5, 3. It's back 5 and up 3. I'm going to find theta prime using this right triangle. In this right triangle, tangent of theta prime is 3 over negative 5, which means tangent inverse of 3/5 of negative 3. Let's just do... I don't want to do negative 3/5. We'll just do tangent inverse of 3/5. Let's do tangent inverse of 3/5. We'll worry about the negatives later. So right now, if I did tangent inverse of 3/5, that would give me 30.96 degrees. That means that that's 31 degrees. This angle right here is 31 degrees. By the way, if I did that with the negative, I just get the opposite of it for now, but I'm going to do the positive for now, and there's a reason why. We'll look at that in a second. So 31 degrees, well, that's not my angle though. My angle, theta, is actually going from here to here. Once again, they're a linear pair. Remember that theta prime is 180 minus theta. Well, that's when we knew theta and we're trying to find theta prime. Now we know theta prime is 38 degrees, and we're trying to find theta. So if I subtract from 38 the 180 and then divide by the negative, I get that theta is 142 degrees. Now we could work with the negatives. We could do all that. Right now, I'm not going to worry about the negative. We'll talk more about that in class. Right now, we're going to treat it as positive just to find this reference angle and then use what we know about reference angles to find the actual angle. Here's our next problem. We know that this problem, or this point, is in quadrant 4. We're in quadrant 4. So that means since we're in quadrant 4, theta prime is 360 minus theta, 360 degrees minus theta. So there's my triangle. I'm going to find theta prime right now. I know that its horizontal distance is 5. Its vertical distance is down 3, but for the purposes of this, even though we know tangent of theta prime is negative 3/5, we're going to do tangent inverse of positive 3/5 just for now. We'll talk more about what we can do later. So tangent inverse of 3/5 gives us, again, lo and behold, 30.96. That's right here, 30.96. That's 31 degrees to the nearest degree. 31 degrees to the nearest degree. If that's 31 degrees, I want to know what this angle from the initial ray being at 0 is. All I have to do is 360, right? Take that angle, that 31 degrees, subtract 360, and then divide by negative. Or do 360 minus it. 360 minus 31 is 329 degrees, is the actual angle for that terminal ray. Letters C and D. See if you make sure to draw the picture for C and D and see if you can set up the trig ratio you're going to use. All right, so you should have for this one in quadrant 3. So you have a negative 5, negative 3, so back 5, down 3. That's going to make tangent positive regardless. And honestly, we could put those negatives, but I want to talk to you about that in class because you can also do it the way that we just did it. So tangent of theta is negative 3 over negative 5, which is positive 3/5. Again, we do tangent inverse of 3/5. Lo and behold, we get 30.96 or 31 degrees. What this means is that our angle went 180 degrees and then the 31 degrees. So that's 180 plus 31, which is 211 degrees. You can figure it out that way. You could also say theta prime equals theta minus 180. Well, theta prime is 31, so add the 180 to it, you get theta. By the way, this is going to work out really well if, I think that we need to talk about this already for A and B. So for A, if I had done this as tangent inverse of negative 3/5, I would have gotten, that I do want to do that, I would have gotten the negative 31 degrees. And you're like, well, negative 31 degrees, how can it be negative 31 degrees? The angle itself is 31 degrees. But think about it this way. It's 31 degrees shy of being the full 180. So if I did 180 plus the negative 31, I would have gotten the same number. Down here, same idea, I had negative 31. It was 31 degrees shy of being the full 360. So if I did 360 plus the negative 31, I would have gotten the same answer. So that works as well. Letter D, 5/3. Let's take a look at that one. Same idea. This one's in the quadrant 1. So I have right 5 and up 3. Tangent of theta prime is, so that's not with a 5 next to it, 3/5. So theta prime is tangent inverse of 3/5, which we already know is 31 degrees. Well, we're in the quadrant we want to be in. From the x-axis to there is that value, so theta is 31 degrees. Theta is theta prime in quadrant 1. See if you can draw these pictures and try this for letters E through H. Try this for letters E through H. See if you can find the angle. All right, let's take a quick look at these. We have here's our picture of negative 8/3. Tangent of theta prime equals 3 over negative 8. If I do tangent inverse of negative 3/8, you can do it as positive if you want, that's fine. Tangent inverse of negative 3/8 gives me negative 21 degrees. So theta prime is 21 degrees. If I'm looking at it as a positive angle, I can do 180 minus 21, or I can do 180 plus negative 21, and I'm going to either way get 159 degrees for theta for letter E. For letter F, we have back 1, down 1. So theta prime, the tangent of theta prime, is negative 1 over negative 1, which is 1, which means that theta prime is tangent inverse of 1. We should know this because it is one of the special angle ratios. It is 45 degrees. But if you didn't know that, you could do that in your calculator. Tangent inverse of 1 will give you 45 degrees. Well, that's in addition to the 180. So add 180 to it, and you get 225 degrees for theta. For letter G, we have right 1 and up 4. So the tangent of theta prime is 4 over 1. So theta prime is tangent inverse of 4. Tangent inverse of 4 is 75.96, so 75.9, so 76 degrees. And theta prime is theta in quadrant 1, so that angle is 76 degrees. And lastly, for letter H, our video notes for day 2, this theta right here, the tangent of theta prime, is negative 2/5, which means that theta prime is tangent inverse of negative 2/5. I'm expecting a negative number. Tangent inverse of negative 2/5 is negative 22 degrees. So theta prime is 22 degrees inside that right triangle, but it's 22 degrees shy. That's why I'm getting the negative 22 of 360. So 360 minus 22 is 338 degrees. And that's how we use SOHCAHTOA to find the reference angle, and the reference angle to find the angle from the initial to the terminal side. This concludes the video part of day 2 of the unit circle lesson. In this lesson, we looked at finding the 6 trigonometric ratios in the coordinate plane and being able to find the angle measure in the coordinate plane. In your practice, we will be looking at identifying patterns and signs for trigonometric ratios on the coordinate plane within each quadrant. Have a great day.